Good morning everyone. In this session we are going to discuss about relational calculus of DBMS. Relational calculus having the two different types. So before entering to the types of relational calculus, first we want to know what is relational calculus. So relational calculus is a declarative language, or otherwise we can call as a non-procedural query language. So before entering to this, so first we want to clarify what is declarative and then what is procedural languages. Procedural language, it's nothing but it is giving the information how to get our required results from the database. That is a procedural language. So rather than declarative language, it's what we want from the database. So rather than explaining how to get the results, so that is a declarative. This is the main difference between these two, procedural and then declarative. Declarative simply in a one word what we want, and procedural language is given it's how we are getting from the database. So this is a basic difference between procedural and declarative. So that relational algebras are called as a procedural languages and relational calculus is a declarative language. So relational calculus doesn't tell us how to get the results from the database. It's only care about what we want. So it's having the two types. One is a domain relational calculus and another one is a tuple relational calculus. What is domain relational calculus means? It uses the domain variables to getting the column values required from the database. So based on some conditions. So the main key idea of the domain relational calculus, it's defining the queries in terms of set of values of the attributes. So rather than the tuples or records, that is my each and every rows it's mentioning as a tuples. Tuple relational calculus, the name itself is there. So it uses the tuple variables and which goes in each and every row of the table and checks whether the condition is satisfied or not for the given row. So it is depending on given predicate condition and it returning the entire row or otherwise a part of the row, depends on the conditions. So now we will see what is tuple relational calculus and how the queries are going to be written. Tuple relational calculus has some query format. It's a t given p of t. T is denoted as our tuple variable and p of t it's a logical formula that is going to be describe the conditions for that each and every tuples in the results must satisfy. So the curly braces is representing indicating the expression is having some set of variables. P of t that has various conditions, so that may combining of the all the logical operators of and or not. So everything we can able to apply here, and it also uses the quantifiers. So here the two quantifiers we are just using. So one is the there exist. So we are just checking the conditions, that is based on the predicate is true whether it is there exist from the row. So that is a thing. And another one is for all. So the q of t is true for all the tuples in the relation R. So these are two quantifiers are using under the P of t. So now we will just write one queries based on some examples. We are just taking the banking example. Under this banking example, so nearly we are just having the 6 tables: branch, customers and account, loan, depositors and borrowers, and each and every table what are all the attributes are available, so it's displayed here. So now the query is finding the loan number, branch number and amount. So these three information we need. The condition is the loan amount over the dollar of 1200. Which loans are having greater than 1200? For those information alone we need the loan number, branch number and amount. So we'll see the table itself, we can easily identify it's all these informations are available under the loan table. So our concept is very simple now. So we can write the query. So the T, it's there exists of loan, table name is a no, and the condition is the loan amount must be greater than the 1200. So if the condition satisfied, all the attributes are going to be checking for each and every tuples. So the next example, the same banking, the query we are just taking, find the name of all the customers having the loan at the Perry Ridge branch. So now we need the two informations, the customers names as well as they must be under the Perry Ridge branch. So if you are seeing the table, customer name, so they are taking the loan, so obviously the borrower, so the borrower, the customer name is available, but the branch is missing, but we need the branch information. Branch information are available under the loan table. So if these two table, from that we are just extracting the customer name who are all taking the loan at the Perry Ridge branch. So first we are just retrieving the customer name from the borrower, and then we are just retrieving the branch name who Perry Ridge branch who are all taking the loan, we are just taking. Then we are just matching with that the branch name and then customer name, and then we are just finally getting our results. So first thing, from the borrower table we are just taking the customer name, and then loan table we are just taking the Perry Ridge branch informations. Then we are just matching with these two things based on the loan number. So loan number is the common attribute from these two tables, so that we can easily take the customer names from who are all having the Perry Ridge branch. So the next one, so one more example, finding the name of all the customers who have the loan at the Perry Ridge branch. So this is the query we just seen in your previous slide, but additionally one more condition, but no account at any branch of the bank. So what is the meaning of the no account means? So there must be as a only the borrower, they are not as a depositors. So we need the customer name, they must have taken the loan at only the Perry Ridge branch, but they are not as a depositor. So this is the condition. So until we just achieved in the previous slide, so only the one condition is added, no account at the branch of the bank. So we are taking the depositor table help here, but they are just simply mentioned the not condition. So they are not belongs to the depositor, the customer name equal to customer. So all the customers we are just taking here, but some of the customer they may have as a depositor too. So we are just using the not condition. So this is the way we are just writing the query for the tuple relational calculus. So the next one, domain relational calculus. So we already explained. So what is domain relational and then what is tuple relational. So now we are just go through how to write the query for these two things. So domain relational calculus query format is this: x1 is x2 x2 till xi from the predicate, the given predicate. So xi is either the domain variables or otherwise it may be a constant. So p of x1 to xn, it's called as a formula composed for the given atoms. So what is the formula? We can mention it. So the same example we can take it for the same query too. So now we can see the difference how we are just writing as a domain relational calculus and then tuple relational calculus. So here the given information LPA, that is defining your loan number, branch number and then account, that must be belongs to the loan amount must be greater than 1200. So this is the given condition of all the predicates, and then what are the things we are just needed from that. And then second, the same query, Uh, so finding all the customers who have the loan from the Peririch branch, and then we are displaying the loan amount. So we are just taking the information, the loan in borrower, and they are having the loan, and the branch name must be as a Peririch. So then we are just displaying the loan amount from that. So like this we have to write the domain relational calculus. So I hope we had get the clear idea of relational calculus. So relational calculus of the database management, we are just achieving in a two different types. One is the domain relational, another one is tuple relational. So thank you.